Hi guys, it's Rob from Raw Balls. Many of you will watch Richard's channel also, and you will have seen the Four Horsemen with their favourite pairings for 2020. My favourite pairing was a clown combo. It's a fire clown male to a pastel vanilla clown female. I try to avoid duplication too much with Richard's channel, but I'd just like to take the opportunity today to go into a little more detail on the genetic side of my pairing and some of the considerations when working with allelic combos and where we take the project from here. So let's take a look. So this is the female, pastel vanilla clown. She is bowl hugging and cooling at the moment. She's been mated up several times this year, so I don't want to disturb her too much. Just get her all in shot there. But you can see that she's a lot brighter than a normal pastel clown would be. You see the yellows, the creamy yellow colour around the side, and how she's kept her brightness, and that's due to the vanilla in her. So here she is, that's the female, and this is the male. This is a fire clown, and you can see compared to the female that he is much higher contrast and also cleaner sides, a little bit less dirty on the sides. The fire is both a colour enhancer or brightener and also a cleaning gene. It cleans up the speckles, the dirtiness along the side of many combos, and you can see he's just sticking his head out there. Let's see if we can get the head stamp for you. He's got that cross with the circle on the head here. You can see that with the almost the bullseye mark and the cross on his head. So that is the fire clown male. So what we're shooting for out of this clutch is the allelic combination of the vanilla cream clown. Everything's going to be clown, but the vanilla cream clown and the pastel vanilla cream clown, or the vanilla scream clown, are the two objectives, and they're the allelic combinations, the combination of fire and vanilla. Let's do a quick recap on how genetics works. I did a video earlier in my YouTube career on genetics, and I'll reference that below, but let's keep it nice and simple. It is actually not very complicated. I like to keep things simple because it's the only way I can understand them too. So just bear with me while we run through some of these genetics, because it will pay dividends when we look at how we take this project forward. So for those of you that missed my genetic series, let me quickly run through the genetics of this pairing. Genetics is actually very simple. These two pipe cleaners here represent the DNA strand for a ball python. This is all the genetic material that is required to make a snake. It contains all the information for the head, the eyes, the intestines, the vent, the skin, everything you need to build a snake. A very small portion of this DNA or genetic code contains the information for skin colour and pattern, and each gene has a specific location on this genetic code that only it has a key for. Only one gene can sit at one location. So here's the female and here's the male, and we know that when we breed something together, hopefully the offspring take half of their genetic material from one parent and half the genetic material from the other parent. So the male is over here, the female is over here, so this half of the male genetic material compare with this half of the female, or this half of the female, and this half of the male compare with this half of the female, or this half of the female. So there are only 4 potential outcomes. Let's just look at that in terms of our clown. Both of these snakes are visual clowns, so we know that because it's a recessive gene, we know the female is carrying 2 copies of the clown gene here on her genetic material, and we know the male is also carrying 2 copies of the clown gene. So when they breed, the female takes half of her genetic material and the male takes half of his, and I think you can see already that it doesn't matter which half of the male we take, we pair to here or to here, or we take this half and we pair to here and pair to here, that you are always getting 2 copies of the clown gene in the offspring. So here's our outcome, 4 possible outcomes, because there are 2 halves of the female and 2 halves of the male. So for the clown gene, every single square, all 4 of the offspring are going to be visual clowns. They each carry 2 copies of the clown gene. The female in this case is also pastel. She carries 1 copy of the pastel gene. When we pair the snakes up, the male is carrying no copies, the female is carrying 1 copy, so only 1 half of her genetic material is carrying a copy of the pastel gene. So when we pair the male, no copies to no copies, that's this square here, no copies, or no copies from the male and 1 copy from the female. Take the other half of the male's genetic material, no copies of the pastel gene, pair it to here, that's no copies from either parent, or pair it to this half of the female's genetic material and there is 1 copy. So the outcome for pastel is that 2 of the squares contain no copies, they do not carry the pastel. 2 out of 4 of the offspring do not carry the pastel gene. 2 out of 4, or 50% of the babies, do carry the pastel gene. Now, in an allelic combination, this is where it gets interesting, because in an allelic combination, in this case it's fire and vanilla, occupy exactly the same genetic address as each other. So the female in this case is carrying 1 copy of the vanilla gene, and the male at exactly the same address in his genetic material. So effectively, as far as the pairing is concerned, these are exactly the same gene. He is carrying 1 copy of the fire gene. So when we pair our snakes now, we take this half of the male, which is carrying 1 copy of the fire gene, and pair it to this half of the female, which is not carrying anything. So 1 copy of the fire gene from the male, no copies of vanilla from the female, or we pair it to this half of the female's genetic code, and now you can see that you're getting 1 copy of fire from the male and 1 copy of vanilla from the female. Take the other half of the genetic material from the male and pair to the female, and there are no copies of anything, that is this square here, or we take this half of the male genetic material and pair to this half of the females, and in this case we get 1 copy of vanilla. So now the outcome is very, very different. We've got, out of 4 babies, we have 1 is fire, 1 is normal, 1 is vanilla, and 1 is carrying a copy of vanilla and fire. So 1 is the vanilla cream. 1 in 4 of the babies statistically will be the vanilla cream. If the female lays 8 eggs, then obviously statistically 2 of the babies will be carrying both genes. And one of the upsides of working with an allelic combination is once you have it, you can't change it, so you can't mess it up. You can add other genes to the mix, but that allelic combination becomes your base for follow-on generations. So that's the upside. The downside is it can be a little bit limiting in that you can't change it, but the downside is that you cannot change that allelic combo. In that vanilla fire complex we can get fire and fire, the super form of fire, which is a white snake, which we don't want. You can get fire and vanilla, which is the allelic cream complex, or we can get vanilla and vanilla, which also has a very strong pattern influence, and we also want to make that in the future too, to form the basis of some of our follow-on projects with the clown. But you can't, for instance, get a super vanilla and add fire to it. There isn't room in the allele for the extra gene, and you also can't pair two snakes that have the necessary combination to do that. Because of the fact that you're working with an allelic combination, the parent snakes will only be fire and fire, fire and vanilla, or vanilla and vanilla. And when you pair those together, you do not have enough copies of the genes, even if they would fit into that address, in order to make a dual vanilla with fire combination. So it's not possible. You cannot produce that snake. The interesting thing here in an allelic combination is that the offspring only have room for two genes at that address. So my potential outcomes are fire and fire, that's the super fire, and that gives an all white snake. So we need to be extremely careful with fire, because we don't want to get an all white snake. If we get an all white snake with two copies of fire, we won't be able to see any of the other genes that are in there. We can also, at that same address, get one copy of fire and one copy of vanilla, which is a vanilla cream. That is the allelic combination. And we can also get two copies of vanilla. So for the fire vanilla allelic combination, there are only three possible combinations we can get. Two copies of fire, two copies of vanilla, or one copy of vanilla and one copy of fire, which is the allelic relationship that we're striving for. Fire and fire we don't want because it's a white snake. Fire and vanilla we do want because it's visually quite striking, and also vanilla and vanilla we do want because it's very striking. So whilst it does limit the potential outcomes for the offspring, it also means that we can't mess it up. We cannot, for instance, get a super vanilla and add another copy of fire. That is physically impossible because the allele is full and we cannot get that gene into the mix. What we can do is to produce a fire vanilla with two copies of pastel and add other genes to it. So that would be the killer version of a vanilla cream, so the fire vanilla combination with two copies of pastel. We can also produce the super vanilla and put two copies of pastel on top of that. Where do we go after that? What genes do we add, and why do we add those genes? So let me walk you through my thinking in the project. Put your comments below if you're thinking along the same lines or you see something different. But this is my thought process, so I just wanted to share that with you guys. This is one of her babies from last year. This is a super pastel vanilla het for clown, and you can see how much brighter the vanilla is making the super pastel combo. The same female was paired last year to a pastel spot nose yellow belly male, and this girl inherited a copy of pastel from the mother and a copy of pastel from the father, so super pastel, and vanilla from the mother. And the head stamp, when you look at the head of this girl, is just so clean and bright and white. That's the combination of pastel and vanilla, and it makes the head look as if it's been carved from marble. So that's the effect that I'm after in my clowns. This is a het for clown, and so the next generation of babies, depending upon what we get, will be complementary to this girl here. When I plug back some of the offspring from this season's pairings to last season's pairings, I stand a chance of getting a super pastel, super vanilla clown. This is another one of the babies. This again is vanilla, but just a single copy of pastel this time, and you can see that the yellows are much more intense. The super pastel version makes the yellows much lighter, and the blushing is less intense with the single copy. And if we look at the head stamp, you can see that the head stamp is nowhere near as blushed. It's a little bit dirtier. So just a single copy of pastel with vanilla in this guy, and this one is also het for clown. Again, perfectly complementary to some of the babies that I'll be producing this year. And I'm also thinking about adding additional genes which would complement that crazy pattern from the vanilla cream without destroying it totally. One gene that springs immediately to mind is yellow belly. When you combine yellow belly with vanilla, it does some awesome things to the flanks of the snake, produces flames and blushing. And with that crazy pattern, if we can get some of that flames and blushing into the snake, I think that would look awesome. And also another gene that springs to mind is enchi. Enchi is a pattern mutation. It causes banding, a reduced pattern with very strong banding in the snake, which I think would complement very nicely the crazy pattern in the vanilla scream. So those are two genes that I want to get into the animal. So let's have a look at two of my het for clown grow-ons that I have in my collection that I'm thinking about pairing back to some of the snakes that I've created either last year or some of the snakes from this current pairing. So the first gene that I'd want to add into this combination is yellow belly. This is a yellow belly het for clown produced by me last season, actually from the same mother. And the reason that I think yellow belly would be so awesome in this combination is, number one, the colour. It would enhance the yellows, but you can also see the banding on the pattern here, and if this girl will let me do so, you can also see the extreme blushing and flames up the side of the body, which I think would complement the vanilla cream pattern or the super vanilla pattern extremely well. So that's the reason that I want to try yellow belly in this combination. So this girl is a perfect complement to that project. And I've also produced yellow belly in combination with vanilla before in another clutch mate from this girl here, and I'll put a picture just on the side of the screen so that you can see that. You can see the effect that vanilla and yellow belly have together, and that's exactly the effect that I'm striving to achieve with the vanilla cream and vanilla scream clowns that we're going to be making. So yellow belly is definitely going to be in the mix. So this is the yellow belly het for clown female, and the other gene that I mentioned is enchi, and this guy here is a little powerhouse. He is actually a pastel Mojave vanilla enchi het for clown male, but again, as an overall pattern enhancer, you can see the banding and the modification to the dorsal stripe that the enchi makes, and it's that look again, that banded look, that I'm hoping will complement the vanilla cream allelic combination and that wacky pattern that that combination produces. So add enchi and see what happens. So this guy here can also be plugged into that project. Again, just to give you guys a feel for Enchi and what Enchi can do. This is a lesser Super Enchi. This is also a male, unfortunately, but there were only 2 males available from this clutch. So the Super Enchi version reduces the pattern even further. So I think at some stage, if we can get Super Enchi into that vanilla cream clown project, that would be also another worthwhile target. So Super Enchi, another super form to add to the Allelic combo. Longer term is Orange Dream. I think that would go quite well, but that's some distance down the road, and I want to see what the other combos look like before I start to mess it up with too many genes. But Orange Dream is definitely one of those genes that we could also usefully add. I'll be offline for about a week, guys, because I'm going to Jakarta. I'll be visiting David Suarez breeding facility and another breeder in Jakarta. We'll be visiting 2 breeders, so I'll be shooting some video in both of those facilities and sharing that with you when I get back. But I won't be producing any videos this week, so bear with me while I take that short break. We're off to Jakarta. Thanks for watching. Don't forget to like and subscribe, and we'll see you next time.